Hi there. In this video, we shall be looking at the electronic configuration, orbitals, and principles governing the filling of these orbitals. To begin with, the electronic configuration of an atom is simply the arrangement of its electrons as distributed into orbital shells and subshells. Hence, what is an orbital? An orbital is simply the area of probability where electrons can be located in an atom. For example, according to Rutherford's model of an atom comprises of a dense nucleus comprising of protons and neutrons with electrons going about in orbit. Hence, we call them orbitals because they are the area or region where electrons are usually found in an atom. There are 4 quantum numbers that define the distribution of electrons in an atom. They are 1. The principal quantum number, 2. The subsidiary or azimuthal quantum number, 3. The magnetic quantum number, and finally, the spin quantum numbers. Let's begin with the principal quantum number. The principal quantum number is usually designated by small letter n. It simply tells us the energy level, or what we call the shell in which electrons can be found. These shells are designated as the K, L, M, N, O, and so on shells of the atoms. And the values of n, the principal quantum numbers, have integral values, that is, ranging from 1, 2, 3, 4, and so on. You should also note that each principal shell has as many subshells as its value of n. For example, the K shell, having the value of n to be 1, has just 1 subshell, and so on for L having 2, M having 3, and so on. The next quantum number is the subsidiary or the azimuthal quantum number, represented by small letter L. The azimuthal quantum number tells us the number of subshells that we can actually find in the principal quantum number. The subshells are usually represented as S, P, D, and F for those that have the value of 0, 1, 2, and 3. The values of L ranges from 0 to n minus 1. So, for an azimuthal quantum number having a principal quantum number of n equals to 1, has its azimuthal quantum number values to be 0 to n, in this case 1 minus 1. Next up is the magnetic quantum number. This tells us the number of orbitals present in each energy subshell. For example, the p subshell has 3 orbitals. The next quantum number we're going to be looking at is the spin quantum number. This quantum number simply describes the spin of an electron in its axis, and it's represented by the letter m, the small letter m. So there are 2 positive or 2 possible values for every spin quantum number, either a positive spin or the negative spin. For example, m, that's the spin quantum number, can have values of negative m or positive m, that is the positive spin and the negative spin respectively. So in an overview, for streamlining purposes, the orbitals we have for an electron include the s orbitals, the p orbitals, the d orbitals, the f orbitals, and so on and so forth. In our next video, we shall discuss in an overview the principles governing the filling of electrons in these orbitals.